Hello viewers, my name is Mr. Adebanjo and I want to welcome you to today's teaching on set theory. Set theory is the topic we are going to be talking about in this series. And what is set? Of course, most of the students will say that they cannot be asked what is set an examination, but the understanding of set can help us. It can help us really understand this topic. So when you are collecting some data or objects, you are collecting a well-defined object. That means you are talking about sets. That is, set is the collection of well-defined object. That is, you know the object you are collecting. You know what you are collecting. I'm collecting 1, 2, 3, 4, 5. It's a well-defined object. I'm collecting. You can see this the diagram you're having on the screen right now. You're having a circle. Inside the circle, you're having some shapes inside the circle now. That means you are collecting a well-defined object. So, and that is what set is talking about, that when you are collecting any well-defined object, group of names, name of persons, dogs, I'm collecting name of dogs, I'm collecting cities, name of a city, name of governors in Nigeria, I'm collecting those names that I'm still talking about set. So set is the collection of a well-defined object you can define, you know them, and when you collect them together, that means we're talking about set. So usually we use capital letters in alphabet to denote the name of a set. We can name our set A, set B, set C, set Z, set Y, and so on. You can use capital letters to name a particular set. Why in any set there must be a member of a particular set, that is the children of a particular set, that is all the elements you have collected, all the objects you have collected, you name it, give it a name, then those objects you have collected is the element of that set. So we use small letters to represent the element of a particular set, or we write 1, 2, 3 numerical values as the element of a particular set. That is when I have set A now, and what we use curly bracket. This bracket is called curly bracket to enclose the element of a particular set. We use curly bracket to enclose the element of a set. So we don't use any other bracket aside from curly bracket in set. You know, we have different types of brackets. We have curly bracket, square bracket, and the rest. But when it comes to set, we only use the only set bracket that is allowed is curly bracket, this type of bracket, and we use curly bracket to enclose the elements of a particular set. Let's say I have set A now will be equal to this element of this set. I can say that set A has this element, set B has this element. So we use capital letters to represent to name a particular set, then we enclose the element of that particular set in a curly bracket. Example of a set is what you're having here. You're having set A having this following element 1 to 12. You can see that we use capital letter A to represent the name of the set. Then elements in it is enclosed in a curly bracket. You have set P having A to A, B, C, D, E, F, G, H, and I as the element in that set. You have set Q having ball as one of the elements, mango, pen, biscuit, and book as the element in that set Q. You have set K having element I, J, K, L, M, N, 6, 7, and 9 as the element in that set what? Set K. We have set X having all even numbers from 1 to 10, so 1 to 20 rather. That is, this set X has even number from 1 to 20 as the element in it. And then you can start saying, listing that out, those elements out. Even numbers are numbers that are divisible by 2. So from 1 to what? To 20. That means I have 2, I have 4, I have 6, I have 8, 10, I have 12, 14, 16, 18, and 20 as the element in this set X. Then set T, all teachers in Ifako Comprehensive Senior High School, all teachers in Ifako Comprehensive Senior High School as the element in that set T. So this is how to name a set, and this is how to enclose. Hello viewers, my name is Mr.Adebanjo, and in our last video we talked about definition of sets and how we can name a set and how we can enclose the element of a set in curly brackets. In this video, we are going to be talking about some terms we have in sets. If you have been to police barrack or army barrack, it's called that when two men are talking or two soldiers are talking, there are some terms they will be using, there are some slogan they will be using that is not revealed to the civilians, that anyone that is not a soldier or policeman will not understand. The same thing we have in a set, that there are some terms we have in a set that we need to understand. And those are the terms we are going to talk about. We are going to be talking about in this video. The first one we're talking about is called universal sets. Universal sets. Universal is the model set from which other subsets emerge. That is, when I have a set and that set has some elements, and I now have other sets, and those other sets I have, their elements are also in the set I have before, the first set. That means that first set is called the universal set. Let's say I have set A, and I have set B and C. And that set A stands for the universal set, while B and C are other subsets of universal set. It means that set B and C, its own element, their elements are also in the set A. That means set A is the universal set of set B and set C. You can have on the screen right now, this is the model set from which other subsets emerge. We denote universal set using U, elongated U, or this Greek word or Greek alphabet you have here, or Greek symbol. So we use U to represent universal set or this symbol. You can see that, let's say this is universal set. All SS3 students of Ifako Comprehensive Senior High School, that can represent the universal set. Then under Ifako other SS3, all SS3 students of Ifako Comprehensive Senior High School, we have other subsets under it. That is, we have science students. Set A representing all science students, set B representing all art students, and set C represent all social science students. You agree with me that set A and set B and set C, they are all inside universal set of Ifako Comprehensive High School. Also, you can see that agree with me that this set A is inside this set. Set B also is inside this universal set, and set C also is also inside universal set. So universal set is like a model set of all the given sets. It's a model set, that is, all that sets are contained inside that universal set. I give you universal set U like this now, and I have set A, set B, set C. That means set A, set B, and set C are inside, their elements are inside this universal set. That's the meaning of universal set. We always use U to represent universal set, or this symbol you're having here. Also, we have null set or empty set. Another term you're going to be talking about under this set theory is called null or empty set. That is, a set is empty when the set has no element at all in it. This type of set contains no element, that it doesn't have any element at all, and it is denoted by, when you have 0 and you now cross it with a sign, this straight line, or you have two curly brackets and there's no anything inside, there's no element inside. That means that set is what? Empty. In this case, I have set A equals to this symbol. That means set A is what? Is empty set. And I have set B having two curly brackets and there's no element inside it. That means set B is also empty. This question is very common in a set. You have question K is equals to, you have this two curly brackets and you have 0 inside it. The answer is set K. This set K, is it empty set? The answer is no, because it is not. It has one element inside. This 0 you're having here is an element. So set K is not empty until you have no element in it at all. That's when K is empty. But so far it has 0. 0 is an element. So that means set K is not what? It's not empty. Hello viewers, my name is Mr. Adebanjo, and I want to welcome you to this video. In our last video, we talked about, we have started talking about some terms that we have in our set theory or sets. We have talked about universal sets, we have talked about empty sets. So if you have not watched that video, please go back and watch the video so that you can catch up with us. In this video, we'll be talking about subsets of a set. Subsets of a particular set are just like a children to a particular set. Let me use parent as an example. Rather, we have parents and the children comes from the parent. So we can say the parent is the universal set and their children are subsets of the parent because they come from this parent. So in this case, now we said that this is the subset is the children or is the child or the children of a given universal set, and we use elongated C to denote subset. That is, all other given sets are inside the universal set. That means those sets are subsets of that universal set. Look at this universal set we have here, having elements A, B, C, D, E, F, G, H. And we have set X, having elements A, B, C, D, E. You can see that all the elements in set S are also in the universal set E. A is here, B is here, C is here, and D is here, and E is here. So that means set S is a subset of universal set E. And how do you write that? Set S is a subset rather of the universal set. Also, look at set Y, having elements A, F, G, H. You can see that all the elements here are also inside the universal set E. So that means set Y also is a subset of the universal set, and that's what you're having here, that set Y is a subset of the universal set. But let's look at set Z, having element B, E, J, K, I. You can see that J, K, I are not inside this universal set E. So that means not all the elements in Z are also in this universal set. So that means set Z is not a subset of set universal set. So that's why you have the elongated C, you now cross it. That shows that set Z is not a subset of set E. We also have another terms in set which we call union. Union is the combination of two or more sets. When you're combining the element of two or more sets together, that means you are finding their union. And we denote that one by elongated U. That is the symbol for union. If I have set A having 1 to 6, and having set B having element 5, 2, 2, 7, 1, 3, 2. If I'm to find A union B, that means I'm to combine the element of set A and set B without repetition. You can see you're having 2 here, 2 here, and 2 here again. So you don't need to repeat 2, 2, 2, 2. No, just write just 1, 2. So you combine the elements A and B together without repetition. That means you have 1, 2, 3, 4, 5, 6, 7 as the A union B. You also have intersection. That means when you have two or more sets, you want to find intersection between them. What is the common element in between all the given sets? In this intersection here, intersection is the intersection of two or more sets as a result of a set that contain only common elements in that set, and it is denoted by elongated N. If I have set S having Ada, Olu, and Akpos as the elements in set S, and have set C having Ejiro, Akpos, and Ilua, it's called as there's an element here that's also in set C as well, which is Akpos is here, Akpos here. So that means S intersection C is Akpos. That means the only element that is common to set S and set C is what? Akpos. So that means we are finding intersection of between two or more sets. You are trying to look for what they have in common. Hello viewers, my name is Mr. Adebanjo. Now in this video, we are still talking about set theory, and we have talked about some terms in the previous videos. So if you have not watched those videos, please go back and watch those videos so that you can understand those things we have talked about in the past, because you are going to be using those terms to solve problem in the future video. In this video, we'll be talking about some more terms such as a complement of sets. How do we find the complement of sets? Complement of set is derived. Complement of a particular set or of a given set is derived when we already know the universal set. That means without universal set, we cannot find the complement of any particular set. So how do we now get complement of a set? Let's say I'm giving set A. Before I can find complement of set A, I have to be given the universal set already. So how do I get complement of set A? Is by getting all those elements that is in universal set and they are not in the set A. That will be to give us the complement of set A. Complement of any set, say P, is the element in the universal set which are not in P. It is denoted by P prime or P raised to power C. That's how to talk about how to get that's how to see check if you are to ask where if you are to ask to find the complement of a particular set. Let's say I have set P now. If I want to find complement of set P, I'll write P prime or P raised to power C. Let's say you are given a universal set U and having element 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the universal set. And I'm having set A 3, 5, 6, 7, 10 as the element. If I want to find the complement of set A, I will write A raised to power C or A prime. And that is the element in the universal set, but are not in set A. That is the complement of set A. Those elements that are in the universal set, but they are not in set A, are the complement of set A. 3 is here, 5 is here, 4, 6 is here, 7 is here, 10 is here. But you agree with me that there's no 2 here, and 2 is in its universal set, so you write 2. 4 is not here, but 4 is here, you write 4. 8 is here, but 8 is not here, you write 8. Then 9 is here in the universal, but it's not here, you write 9. So the complement of set C, so it's A is 2, 4, 8, 9. Then also we talk about cardinality of set. Cardinality of set is talking about how many elements do you have in a single set in a given set. How many elements do you have in the set given to you? So let's say I have set B having elements A, B, C, D, E, F. Then if I have to find the cardinality of that set B, that means they write small n and close in bracket set B. That means this one is talking about how many elements have set B. That's cardinality of set B. And how many elements do you have in set B? You have 6. You count the elements, you have 6 elements. I have set A having 1, 2, 3, 4, A, B, C, D, E, F, G, H. The question asks me to find n, then into bracket set A. That means talking about I should find cardinality of set A. That is how many elements has set A, and that is 9. So that is the end of this video. In our next video, we're going to talk about more terms we have in a set. Do subscribe to our YouTube channels if you have not, so that you can receive more videos when you upload videos. Like the video, comment on them, and we'll see you in the next video. Thank you and God bless you. Hello viewers, my name is Mr. Adebanjo, and I want to strongly welcome you to today's teaching. In a couple of videos we had in the past, we have talked about sets, what constitutes a set, and we have also talked about some terms that we have under sets, such as subsets of a set, stuff like inverse set, intersection of sets, union of sets, and so on. But in this video now, we are going to talk about range sets. Range sets. And what this is saying is that there is a way we can code the element of a particular set. Instead of revealing the element of that particular set, we code it in such a way that we need to decode it before we can use those elements of that set. And that's what the range set is talking about. When we put the element of a particular set in inequalities format, and that is a range set, then you will need to list the element of that set before you can use the set for anything. An example of what I'm trying to say is what you are seeing on the screen right now. You have to list the element of the set G now. But if you look at the element in that set G, it's such that this set G has X elements in it. Set G has X element in it, such that they now give us the range of values of that X elements. They're now giving the range of values of set X elements. That if we have some element that in place of X here, but those elements range from this value to this value. How can we get this? We are having that 1 less than X and S less than 5. And how do we solve this? That means those elements, if 1 is less than X, that means X is what? Greater than 1. That's what it implies. That means those elements in set G are numbers greater than 1, but S is less than 5. Those elements is less than what? 5. I'll come again. Those elements in G are, that is, we are having 1 less than X. That means S is greater than 1. That means those elements are greater than 1, but they are less than what? They are 5. And what are those elements? If you list those elements, elements that are greater than 1, that is value that are greater than 1, they are 2, 3, then 4, but less than 5. That means you are going to stop at what? 4. So we have 2, 3, 4, 2, 3, and 4. So those the elements in G here are 2, 3, and 4. If you look at the set L here, given that that element in set L are Y, such that Y is from you're having 16 less than Y here. That means Y is greater than what? 16. If 16 is less than Y, that means Y is greater than 16. That means those elements are greater than 16. They're not starting from 16. So that means, but less than or equals to 19. That means those elements could be less than or equals to what? 19. So if those elements are greater than 16, that means I have 17, 18, less than or equals to 19. That means 19 is also included. That means the elements in this set are 17, 18, and 19. So if you look at another set you're having here, you're having set M here, having A elements in it, but the element element A is from, you're having 25 less than or equals to A. 25 less than or equals to A. That means A is greater than or equals to 25. In this case, that means 25 is part of the element in set M. So that means I have 25, 26, 27, 28, 29. But those elements is less than what? 30. So that means 30 is not part of it. That means the highest number there is what? 29. That means I have from here 25 to what? To 29 as the element in set what? Set M. Then I have set N having B elements such that 3 is less than or equals to B, less than or equal to what? 6. That means B is greater than or equals to 3 and B is less than or equals to what? 6. So what do I have? That means those 3 is among the element and 6 also what? Among the element. Less than or equals to. It could be less than or equals to. So that means I have 3, 4, 5, 6 as the element in 6. Another way of setting range set is we're having elements set W here, having X elements such that S is an even number from 5 to 15. We should know what an even number is. Even number are number that. So we were talking about this solution of this range set. That is, W is a set and W is a set as X elements shows that S is an even number from 5 to 15. That means even numbers are numbers that are divisible by 2, but those numbers are from 15 to what? To 5 to 15. And the first number should be what? 6, 8, 10, 12, 14. So those are the elements in set W. Then also we have set R having K elements such that K is an odd numbers between 2 and 11. Then what are odd number? Number that are divisible by what? By that are not divisible by 2, but between 2 and what? 11. This the first number will be 3, 5, 7, and 9. So those are the ways in which you can give range sets by coding the element of that particular set, and we will need to decode it before we can now you see the element of that particular set. Now we are going to solve some question on sets in this video. Question we are going to be solving that if you are given this inverse set from 1 to 10, given set A, set B, set D. Question will say you should find the A complement of the set A. And we have talked about how we can find the complement of a particular set in a couple of videos before back. Please, if you have not watched, go back and watch. And you should know by that without inverse set, there's nothing like complement of a particular set. If set A is having element 2, 3, 5, 7, if you want to find a complement of this particular set A, that means those elements in the inverse set, but they are not in the what? In the set A, are the complement of set what? Set A. And that's what we have here, that set A is equal to 1. Consider that 1 is in inverse set, but it's not in set A. 4, 6, 8, 9, 10. Those elements are here, but they are not in what? In set A. Those are the complement of set what? Set A. Then question number B, find A intersection B. A intersection B also we have discussed in the past. Go and watch and know what you find intersection B. That is those common elements in set A and set B, which are 2, then 5 and 7. And what we have here that A intersection B is 2, 5 and 7. We have A union B complement as well. Sorry, C, A intersection B complement. First of find A intersection B first, then find when you now what you now get, find the complement of it. You have already gotten A intersection B to be 5, 2, 5, 7. The A intersection B complement will be elements in the inverse set that are not in A intersection B complement. Elements in the inverse set here, but they are not in the A intersection B. They are the A intersection B complement. So those elements are 1, 3, 4, 6, 8, 9, and 10. Also, we have to find the A union B complement, and that will not be possible unless you find A union B. Then when you now get your A union B, you can now find A union B complement. What's the meaning of A union B? A union B means combine A, set A and set B. All the elements in set A and set B, combine them together without repetition, and that's what A union B. Then to get A union B complement, those elements in A union B, but both elements in the inverse sets, but they are not in A union B, are the complement of A union B. So if you look at this now, we have A union B to be 1, 2, 3, 5, 7. The A union B will complement will be 4, 6, 8, 9, 10. Those elements in the inverse set, but they are not in this A union B, are the complement of A union B. Then D complement is by finding, if you want to find D complement, D complement, for find the D complement, then complement it again. So this is set D 1, 2, 5, 7. Complement it by finding the element that are in the inverse set, but they are not in this set D. That will be D complement, and that gives us D complement is 3, 4, 6, 8, 9, 10. Then complement again, D complement again. That will be element in the inverse set, but they are not in this set, and that is 2, 5, 7. That means D complement is same thing as set D. D complement is same thing as what set D. The elements here are also the elements in D here, so they mean the same thing. Then you have A union B complement. Your set A is B is this, then set B is D. Find the complement of set B first. 1, 2, 3, 6, 7, 6, 8, 9, 10. Then find A union B complement. Combine set.
Hello viewers, my name is Mr. Adebanjo and I want to welcome you to today's teaching on set theory. And we have explained the concept of set in the couple of videos that we have made in the past. So please, if you have not watched that, quickly go back and know all the rudiments, all the elements, all the terms you are meant to know on set. In this video, we are going to be solving this WAEC past question. And the question was 2003. Question number 8 there, still on set. We are told that set A has element 1, 2, 5, 7, and set B has element 1, 3, 6, 7, and they are subset of a universal set U. And the universal set U has elements from 1 to 10. So we have to find A complement and A intersection B complement, A union B complement. We have to also to list the subset of the subset of B, each of which has 3 elements. So this is the question we have to solve in this video. And from our video, from the couple of videos we made in the past, we have explained what complement of a set is all about. That is the element in a inverse set that is not in particular set is the complement of that set. So in this case, we have the inverse set to be set. Inverse set will have element of 1 to 10. So therefore, the complement of set A here will be element in this inverse set that is not in set A. This element in this inverse set that is not in set A are the complement of set A. You can see that we have 1, 2, 3 is not there. So that means 3 is in there, is a complement of set A. One of the elements in a complement of set A. Then 5 is here, but there is no 4 here. So and 4 is in the inverse set, so 4 will be there. Then 6, 8, 9, 10. All these elements in this complement of set A, they are not in A, but they are in the inverse set. So that means the complement of set A is 3, 4, 6, 8, 9, 10. That's the element. So we have to find A intersection B complement as well. We cannot find that straight unless we know A intersection B first. and we should know what meaning of we know the meaning of intersection. That is those elements in A and B, those elements that are common to set A and set B at the intersection B. So we can see that one is here, one is also here, seven is here, and seven is also here. So no other element. So that means intersection B is 1, 7. And if that should be the case, they are now looking for intersection B complement. That would be those elements in the universal set that is not in A intersection B. And those are elements are 2, 3, 4, 5, 6, 7, 8, 9, and 10. Also, you have to find A union B complement. All you need to do is to find your A union B. When you now get your A union B, you can now find A union B complement. And what is A union B? We have also defined what union is all about in a couple of videos. So we have under this series. So you are free to watch that. So how do you find A union B? Is by combining the elements in A and B together without repetition. So one is here, two, 3, 5, 6, 7 are the element in A union B. The A union B now complement. We can now find those elements that are in the universal set, but not in A union B. That's the A union B complement, and that will give us 4, 8, 9, and 10. So now, then the last question you have to find the subset of set B, which has three elements. Subset of set B, which has three elements. The first one you have 1, 2, 3. Next one you can say 1, 3, 7. Next one 3, 6, 7, and last one will be 1, 6, and 7. So those are the sub. All you consider all these elements you have here, all these sets you have here are also in this set B, and that means they are subset of set B. So that is the solution to that why question 2 and 3. Question number 8 is still on a set. Viewers, my name is Mr. Adebanjo, and in this video we are going to solve another wire pass question on the set theory. And if you have been following this series, we have been solving questions on the set theory. And in this video also we are still going to solve another question so that they can help us understand the concept on the set theory very well. And if you have not watched the explanation we have made so far on set theory, the meaning of set and the terms that we have in set, please go back and watch those videos so that you can really understand what you are talking about here. And the question says that you have set A having element 2, 4, 6, 8, and we have set B having element 2, 3, 7, 9, and set C having X element. Set C has X element such that 3 less than X less than 9 are subset of universal sets U. Universal set U having element from 2 to 9. So if you look at this set now, set A, set B, we know their element quite all right, but set C is the element of this set C is not given. So we are the one that will now try to know list the element ourselves. So and I've explained how we can decode a particular set given in this format in the previous video that we have made. So you can watch those videos so that you can really understand how to list elements given of a set given in this format. So we are given the universal set and we have to find A intersection B complement intersection C complement. Then you have to find B, A union B intersection B union C. The first task we have here is to first of all list the element in set C. So how do we do that? This one is saying that set C has S elements, which ranges from 3 to less than X, less than a 9. That is, 3 is less than X. That means X is greater than what? 3. That means the element we are listing there will start from 4 because S is greater than 3. So those elements is going to be greater than 3, but less than what? 9. So that means we having the element in set C is from 5, 4, 5, 6, 7 to 8. It is greater than 3, but less than 9. So, and that is the element in set C. So For this question, to find this solve this question now, we need B complement. And the B complement is the element in the universal set that is not in set B at the B complement. So we have that to be 4, 5, 6, 8. We also need C complement here, which is the element in universal set that is not in set C. And this is set C here. And those elements are 2, 3, and 9. So before you can simplify everything we have here, before we need to get what you have in the bracket, which is B complement intersection C complement. We have our B complement here and we have our C complement here. So intersection is saying that what are the elements that are common to the two sets we have in here. We can see that there is no element that is common to both sets. So that's why we are saying that B complement intersection C complement is what is an empty set. No element is that is common there. So if this element, if this set here is empty, so A intersection empty set should give out an empty set. I see there's no element that is common to A and that this empty set we have here. So that means the A intersection B complement intersection C complement will give us empty set. So for B part, we have A union B. That means we need to forward get our A union B first. And A union B is to combine element of set A and set B together without repetition. And that will give us 2, 3, 4, 6, 7, 8, 9. Then we will need to get B union C as well. B union C is to combine the element of B and element of C together without repetition as well. And that should give us 2, 3, 4, 5, 6, 7, 8, 9. If you look at it very well, this set B and set C, combine it. Then we need to get this intersection this. So the element that is common to this and this are the intersection of them. So the A union B intersection B union C will give us the element that are here and are also here. And that should be 2, 3, 4, 6, 7, 8, and 9. So if you look at it very well, you can try to check it very well. If you are truly you have truly understood what we have talked about on set theory, all the questions we have solved so far, and all the examination questions we have solved, and you have been able to watch all the videos you have made so far on set, and you truly understand, and you want to examine yourself, you want to evaluate yourself, you can examine yourself using this couple of questions I have on the screen right now. The first one say that if uh, E is the set from having element 1 to 20 and A, B, C are subset of set E such that set A is a multiple of 5, set B has an element of multiple of 4, and set C multiple of 3, leaves the element of set A, set B, set C, intersection B, intersection C, B intersection C, then show that A intersection B union intersection C is equals to intersection B union C. Then second question is saying that set A has the element of 1 to 5, 1, 2, 5, 7, and set B has the element of 1, 3, 6, 7 are subset of the universal set U. So universal set U has elements from 1 to 10, where to find A complement, intersection B complement, intersection A B complement. If you are able to solve these questions and you want to know whether you are right or wrong, all you need to do is to drop your answer in the comment section of this video and state the values of your answers one after the other, and I will respond to it if truly you are right or wrong. And if wherever you have a issue, you can drop a comment on this video and I'll respond to them. So if you like the series, you can comment on it, like, and share the video. And in the next couple of videos you're going to make now, we're still going to talk about set theory, and then we'll be taking it. We'll be talking about Venn diagrams, how you can solve set theory using Venn diagram, and it's going to be interesting as well. So uh, keep following us, keep liking the good work we are doing, and as you do so, may the good Lord bless you. Thank you, and God bless.